tomorrow will be better. Let us stay a little bit more in physics, but this time around in the domain of electricity or electrical energy. We have been given a circuit diagram on the board as so, and then we are asked to find the total resistance in the circuit, and then two, to find the total current that flows throughout the circuit, and then last but not the least, to find the current which flows through the 6 ohm resistor. Follow me. Solution. Now the first thing I would like to say here is that when we have this kind of situation here, we see that the 5 ohm resistor is connected in series with the 6 and the 3 ohm resistor. On the other hand, the 6 ohm is in parallel with the 3 ohm resistor. Now how do we handle this information? Now, we've been asked to find the total resistance. The total resistance, just to remind you that this is a past GC question, I think 2021 ordinary level. The total resistance is given by the resistance in series plus the resistance in parallel. Okay, let's start with the resistance in parallel. The resistance in parallel will be given as so. Now the formula for resistance in parallel says 1 over total resistance is equal to 1 over resistor 1 plus 1 over resistor 2 plus and then plus 1 over resistor n in the situation where we have n resistors in parallel. But now since we have just 2 of them, we're going to use a shortcut of this formula, because normally for these 2 resistors we're going to have 1 over R total, which is going to be 1 over resistor 1 plus 1 over resistor 2. But this whole thing is going to boil down to resistor total is going to be now the product of these resistors, R1 times R2, and then the sum plus R2, like this. Okay, so but if we have more than 2 resistors in parallel, this situation will no longer work. We'll have some other different thing to do, but this is a general formula which works always for n number of resistors which are in parallel. All right, I'm going to wipe this off quickly and then use a shortcut. So I will say, but resistance total in parallel is going to be equal to R6 times R3 plus R6 divided by R6 plus R3. Beg your pardon. So this is going to give me 6 times 3 all over 6 plus 3. And if you punch on your calculator very well, you have that this gives us, here we're going to have 18 all over 9, giving us 12 ohm. Guys, physics is very sensitive to units of physical quantities, all right? So now, therefore, there's only one resistor which is in series with this other set of resistors. So we have that the total resistance of the whole circuit is going to be the resistance in series, which is 5 ohm, plus the resistance in parallel, which we had as 2, giving us a total resistance of 7 ohm. So this is it for question A. Now for question B, which says, find the total current in the circuit. We know that the formula, Ohm's law, states that V is equal to IR. So to find I total, this implies that I total is going to be equal to V total all over R total as well. Now what is V total? According to this diagram, the total voltage, or the EMF if you want, is 28 volts. Okay, so this means I total is going to be equal to 28 volts divided by the resistance total, or the total resistance, which just had as 7. And all of this is going to boil down to 4 if you calculate very well. 4 amperes this time around, okay? Because the ampere is a SI unit for current electricity. Here is the heart of our problem. Find the current which flows through the 6 ohm resistor. How is this going to happen? First things first, let's establish a formula which we need to calculate this. We will say, according to Ohm's law again, we will say that the current flowing through the 6 ohm resistor, let's call it I6 as it's been called in the diagram, will be given by, according to this law, will be given by the voltage across the 6 ohm, or the PD if you want, the potential difference across the 6 ohm divided by the resistance of the 6 ohm resistor. But watch out here, we do not have the PD across the 6 ohm resistor, but there are a couple of things we know. The first of which is, when components are in parallel, they have the same PD across them, okay? So whatever value which we're going to obtain for the voltage here or the PD here will be the same for the 3 ohm resistor. And we also know that when we add up the PD here plus the PD here, it should give us the EMF or the total PD, okay? That's the first thing we know. Now the second thing we know is that when components are in series like this, the one thing they have in common is the current drop, okay? Which means the current, which is we just obtained the total current of the circuit. This is the current that flows through the 5 ohm resistor, and this is also the same current which comes here and splits for this. But do not make the mistake to think that since they are in parallel, the same amount of current is going to flow. No, they have different resistances, okay? This one will resist current more, and therefore only little current is going to flow in here, and the greater part of the current will flow down here. But what they have in common is the potential difference, okay? So with this in mind, let's find a way to obtain V6, the potential difference across the 6 ohm resistor. Now, one other thing, let's apply one of the things I just said, or one of the two things I just said to obtain V. We know that V total, which is 28, is actually given by V of the 5 ohm resistor, or V across the 5 ohm resistor, plus V of the parallel. What do I mean by V of the parallel? Remember I just said the potential difference across components in parallel is the same. So if I say V in parallel, I'm talking about V6, which should also equal V3. So here I'm going to just specify that, but V in parallel is the same as V6, which is the same as V3, right? But now we have this. We do not know this, and we don't know this either. But we have information to obtain V5. Okay? We will say, but V5 in accordance with Ohm's law is going to be equal to I5 times R5. Now I can hear some of you asking yourself, what is I5? Of course, I5 is just the current which flows in the circuit. Why? Because the 5 ohm resistor is connected to the battery in series, okay? So the same current that the battery delivers is the same current that this 5 ohm resistor receives, okay? So we can just make that comment here and we say, but I5 is the same as I total, which we already obtained, okay? So with this, let us break down this formula and compute for V5. We say, so V5 is going to be equal to total current, which is 4 ampere times the resistance of the 5 ohm resistor, which is just 5. And this gives us 20 volt, guys. Unit for PD is 20 volt. Now, having had V5, let's put it here to obtain VP. So we say, therefore, VP, which is actually going to be V total minus V5, is going to be 28 minus 20 volt, and this is nothing else but 8 volt. So I would say, therefore, VP, which is also V6 and which is also V3, is equal to 8 volt. Now we have V6, so we can easily calculate I6. We will say, therefore, I6 is going to be equal to, we will have here that V6, which is 8, divided by R6, which is 6 ohm, and this gives us nothing else but 4 on 3. You can always break this down and you obtain something in ampere. I don't mind if you leave it like this. Now, like I said, here at this junction, we call this a junction. There's a 4 ampere which arrives here, but when it arrives here, it has to be split into an I6 and then an I3. Now we can realize here, and before I make this observation, when this current splits here, when it comes back to this other out junction, we should obtain back, if we place an ammeter here, we should get a reading of 4 ampere, okay? So which means the sum total of the two currents flowing in these two resistors should still give us 4, okay? So if we have that I6 is 4 on 3, and I ask you therefore find I3, you can just obtain this by subtracting this current here from the initial current which went into the junction, because usually tomorrow has to be better. Thank you.